This last example, we want to use the following expansion, x squared plus 4 over x to the 12th power. We want to do two things. We want to find the coefficient of whatever the x to the 6th term is, and then we want to find whatever the constant term is. And really what this means is when there's just a number, or we can think of the constant term as the x to the 0 term. So let's start off with finding x to the 6th power, the coefficient here. So there's a couple different ways you can think about this, but if this is going to be our a, if a is equal to x squared, and this is going to be our b equals 4 over x. To find that x squared, or x to the 6th term, I'm basically looking for where in the binomial expansion I just have x to the 6th. And I'm going to get that from multiplying different powers of this a and this b together. And so when I'm looking for this x to the 6th term, I don't really care about any non-x values in this a and this b. So what I can kind of do is I can kind of just imagine like a sidebar over here, where I know that there's going to be some x squared to some power a times 1 over x to some power b. And the reason why I'm writing 1 over x here is because that 4 doesn't really affect what the power of my term will be. And so I'm just going to eliminate any distracting numbers and just kind of leave everything in terms of just pure x's. Another way I can write this is x squared to some a power times x to the negative first power to some b power. And I want this to equal something times x to the 6th. So my goal is to make this whole thing equal x to the 6th. And there's different ways you can approach this. There's kind of an algebraic way where you can set up an equation and solve, but I think it's almost easier just to remember that whatever this a power plus whatever this b power is, they have to sum to 12. And then I think it's almost easier to kind of guess and check your way around this thing. If I want this to come out to be x to the 6th, then, well, let's just pick a random guess. X squared to the 5th power and x to the negative first to the 7th. Those two numbers add up to 12. So this could be a possible, this will be one of the terms in this binomial expansion. And this would come out to be x squared, or x to the 10th, times x to the negative 7th, which would be x to the 3rd. That's not what I want, so I know the powers can't be 5 and 7. So that means that 5 and 7 does not work as my respective exponents for these terms. Let's get rid of this, pretend that never happened, and let's try a different guess. So why don't we try 6 and 6. So if I take x squared to the 6th power times x to the negative first to the 6th power, then that'll be x to the 12th times x to the negative 6th. I add those exponents, and that is x to the 6th. So what does that mean? That means that the powers of my terms, or of my a and my b in this term, should be 6 and 6. Now, if you remember, that general equation, the r plus 1th term, is given by 12 choose r times a to the r n minus r power times b to the r power. This r, or the power of b, is whatever the r value is in this expression. So that helps us because that means that by finding the correct powers for this a and b, this 6 is our r value. So that was really helpful because now I'm ready to go back to my original a and my b, and I know that r is equal to 6 when I get a term that has an x to the 6th power in it. So let's apply this equation. Now what that means, I'm actually looking at my 7th term since this is the r plus 1th term. So that's going to equal whatever 12 choose 6 is, times my a, which is x squared, to the n minus r, so that's 6th power, and that's the same thing we found over here, times 4 over x to the 6th power. This will have a coefficient of x to the 6th. Now remember, this question is asking me to find just the coefficient of x to the 6th. So I'm not going to spend my time expanding all this stuff out. And actually, I know that it already has an x to the 6th in it. The only thing that's missing is what the coefficient is. But what I'm trying to say is I'm not going to waste my time looking at anything that's not a coefficient now. So really, the things that become coefficients are just whatever the number 12 choose 6 is equal to. And then I'm just going to look at this 4 to the 6th power. That's going to be my coefficient. Since I just lifted out all the coefficients from this term in the expansion. So now let's go to the calculator and let's get what 12 choose 6 is equal to, and we'll multiply that by 4 to the 6th power. So I'll go to math, go to probability. I want 12 choose 6, and I want to multiply that by 4 to the 6th power. And that comes out to be this massive number here. So let me get that down. So that's 3,784,704. So this is the coefficient. If I were to take all that time to expand this polynomial, the coefficient for the 7th term when I have a degree of x to the 6th is 3,784,704. So a little bit more complex of a problem, but I think this is a little bit simpler than doing that full expansion, and we're just zoning in on this one term. So why don't you try an example kind of like that? I forgot part B. I got to find the constant term. All right, so this is really the same type of a thing. The constant term is when the degree of the x power is 0. So how do I do this? It's really the same idea. I'm going to look for, if I kind of isolate the degrees of my a and my b, I have an x squared to some power times x to the negative first to some power. And again, it's just taking the degree of what my a and b is. I'm kind of ignoring this 4 for just a minute here. And I want this to equal some x to the 0 power. And so I also know that a and b sum up to 12 still, since this is an expansion to the 12th power. And so again, you can kind of guess and check and play with your possible exponents. But let's just throw in x squared to the, 5th, and x to the negative first to the 7th. And that's too high. So if I'm thinking about, well, how do I need to adjust my guess? I need to make my powers go down to 0. So that means I'm going to have to decrease what my x squared exponent is, and I can increase what my x to the negative first exponent is. And why don't we try this guess? Let's make this x squared to the 4th power times x to the negative first to the 8th power. And that'll equal x to the 8th times x to the negative 8th, which is equal to x to the 0, which is equal to 1, which means that this is what's going to produce my constant term. So what does that tell me? That tells me that the r value here is equal to 8. And I'm going to use that same formula that I had before. This is the 9th term. It's going to equal 12 choose 8 times x squared to the, what power did I say? To the 4th power. And then 4 over x to the 8th power. Notice that now I'm actually using what the proper b value or the b term is in this binomial expansion, because I know that the degree will work out, so I need to actually use that coefficient or that actual term in there now. So now all I'm concerned with, again, is the coefficient. So really I'm just focusing in on whatever this number is and whatever this number is. So the coefficient, and actually technically the coefficient is the term. Since we're talking about a constant, this is what would be whatever in front of, this would be whatever is in front of x to the 0, and it's just a coefficient anyway. So I'm going to figure out what 12 choose 8 times 4 to the 8th is. So let's go to the calculator and we'll type that in. And that gives me, whoa, this massive number. So let me see if I can get this. 32,440,320. This is the constant term if you were to expand this entire binomial. So there you go. Once again, we kind of identified what those a and b powers would be for my a and b terms. And then from there, we're going to our n plus 1th term formula. So why don't you try the same thing in this example? Now, all I want you to do is I just want you to find the coefficient of the x cubed term in this expansion. So pause the video, give this one a shot, and see how it goes. All right, and here is my workings out for this one. You can kind of see the process. I try to throw some arrows in there for you. And the final coefficient is a little bit more manageable of a number, negative 4,320.